Hey folks, welcome to this episode on isotopic calculations. So we have reviewed what an isotope is. If you want to see the lesson, you can look at the description below. But what we're going to look at is a simple calculation to determine average mass. Now, the mass that you see on the periodic table for all the elements, that is the average mass. So let's say, for example, we had standard atomic notation of hydrogen. It has one proton and it has a mass of 1.01 AMU. Or grams per mole if you're into the stoichiometry. But right now, what that means is that it has a mass of 1 from that proton, but why does it have a decimal? That decimal comes from what we call a weighted average of all the isotopes. Now, a weighted average looks at not only the weight or the mass of all the individual isotopes, but also the abundance of it. So if we have more of one isotope and less than another, we will have the weight reflect that. The equation that we use for this is going to be the average mass. The average mass is equal to the percent abundance of the first isotope times its mass, M1, plus the percent abundance of the second isotope times its mass, plus any other isotope. So if we have 3, 4 isotopes, we just continue on this trend. Now, I've presented you a question here that we can really just do as a thought question, but we'll also calculate it to kind of prove our point. So we have 2 isotopes. Isotope A, again, this is not referring to any kind of specific element, it's just isotope A, has an abundance of 75% and a mass of 14 AMU. Isotope B has an abundance of 25% and a mass of 15 AMU. What is the mass of the element? Now, when we think about this, you should see that 75% of that mass is 14 AMU. It's of the lighter isotopes, whereas 25% of the mass is made up of the heavier element. So think about this. Shall we see that final mass closer to 14 or closer to 15? Well, the answer is that we should see it closer to 14 because 75% of the total collection of this element is made up of this lighter isotope. So we should see this closer to 14. Now, some of you might be able to do this in your head and you might already have an answer. Let's go through and let's calculate this out. So in our case, isotope A or isotope 1 is going to be 14 AMU and 75%. Now, first thing we need to do is we need to convert this into a decimal, so 0.7500. So we just take that divided by 100 and we get our decimal. So let's do that. So we have 0.7500 multiplied by its mass, 14.000 AMU. And then we have the percentage of the next one, which is 25%, or in a decimal, 0.2500 times 15.000 AMU. Now make sure you carry those units over because we'll be able to have our final unit in the appropriate one. Now, when we do this calculation out, we will see that we get 10.500 AMU. Okay, so this is just a ratio here or a decimal. So that unit comes from carrying that over. Plus, we get 3.7500 AMU. All right, so now since they are in the same unit, we can add them together. And our final answer will be 14.250 AMU. That is our average mass. So the weighted average of this isotope collection is going to be 14.25, which makes sense because 75% of it is made up of that lighter element and 25% of it is made up of that heavier element. I hope this helps. Please take a look at the other videos. And if you haven't done so already, please like, subscribe, and hit the bell for notifications on when new episodes drop. Thanks very much. Have a wonderful day. We'll see you next time.